Hi y'all, welcome back. It's Jeff. This video is a continuation of our work to get to know what's happening in our electronics learning laboratory kits. Last time we saw a discussion introducing resistors and some of the features of resistors that we can be aware of. This time we're going to see a DC voltage source. DC means direct current. Direct current is in opposition, or I guess the opposite of electronically alternating current, AC. This is a discussion that is way beyond the context of today, but a lot of the electronic power distribution networks in our society run on alternating current, and alternating currents are actually a way that we can encode information in electricity uniquely. So a lot of times like a pure sine function. So basically electrons are moving back and forth. That's what happens in AC. DC is a constant, you might say, change in potential. We'll talk all about that. These things provide constant changes. That's why they're called DC voltage sources. We've labeled ours with a plus and a minus. This was really cool. The students that designed this actually designed the sticker without me asking for it, which is awesome. So the positive lead of this source is the red one. The negative lead is the black one. We're going to see that when we connect this, on the other side it has a cap that connects to a 9-volt battery. So in particular, we can connect this thing and it's now powered. One thing that I'll say, I don't feel I'm touching myself with these two prongs, and there's no pain there, so there's no harm of getting electrocuted, which is really nice. This source is now powered, and the voltage potential between these two leads is 5 volts. We're going to talk about an analogy between voltage and height. So voltage is a measurement of the potential to create flow. We'll talk more about that in just a bit, but I wanted to show you when we connect this, I can now connect this to a circuit through the breadboard. So we just go ahead and connect the black lead and the red lead into the little points on that. And now the voltage difference, you could think about this as like a 5-foot gap between the black and the red, which means if I put something at the red, force, if it was actually height, would force it down to the black. So there's an actual force between these things that allows us to move items. In this case, the items we're going to move are charged particles or electrons. And that's where the analogy kind of breaks down a little bit. We'll talk about that in a sec. But the major idea is that this circuit element allows us to move electrons, allows electricity to flow when we attach it to a circuit. So I'm going to go ahead and just disconnect this for a second. We'll get much deeper into how voltage sources work and ways to think about them, but I wanted to show you a little bit about how we're going to look at these. This is the actual physical DC source. Again, it's a 5-volt source. When we draw circuit schematics, we can use this circuit symbol to represent this physical component. So remember that the schematics, the ideal drawings, are mathematical models of the corresponding real physical circuit element. We'll talk more about the dynamics of that model as we get into this, but the major idea is you're kind of seeing this thing is a physical object that I can touch in life. The corresponding voltage source pictured here is an ideal mathematical model to represent that. I will say there's some good work to be done here. I have not finished this yet. In Fritzing, I talked about this already. These circuits that you see in front of us were custom built. So the world has not seen these prior to this project coming to existence. Mike Sassnet, Chris Sakurada, and Hayden Sato, you all are amazing. The reason that that's useful is that when I am doing this in Fritzing, so let me say this. I just went down to the breadboard, put it a half. I can rotate this. Let's do rotating 90 degrees clockwise. So you can kind of see this thing here. Fritzing does not have this source involved. There are ways that you can custom build your new components into Fritzing. So in particular, one thing that you can check out here, sparkfun.com So let's do sparkfun.com. It's a very, very fun website to learn electronics. Most electronics that I'm teaching you right now, I taught myself just by reading. And I have a lot to say about this, but anyways, SparkFun has this fun blog. It sells really fun Arduino things. And one thing that I wanted to note here is there's some good work that needs to be done on this project right now. So one thing that I'm going to say is how to build custom parts in Fritzing software, and we'll just add the word circuits. There it is. So you see that? Instructables, how to make custom PCB shapes. That's not quite what I want to do. How to build custom parts. Yeah, make your own. Yeah, you see that? Make your own Fritzing parts. Learn at sparkfun.com. So SparkFun is kind of a fun support that was made by some people at a university. In this case, they're actually running you through how to build your own part that doesn't exist in that. And the reason that they use that is that they build a bunch of custom parts and then they want to integrate those into diagrams for education purposes. I have not yet created the Fritzing image of this DC voltage source that looks like this thing. And the same can be said about the DC current sources. That's a project that needs to be done. I'm going to show you how to hack that in just a minute. But if those of you that are following along at home, if you wanted to do that, it would be kind of a nice resource to have. What I'll say here is, in order to replicate these parts, what I can do is go down to this little battery right here and then pull the battery out. And this is not a 3 volt, it's a 9 volt. Now, of course, in electrical engineering, if I show this to an electrical engineer, they're going to say, oh, that's 9 volts DC voltage. So you can hack it by just like putting a black mark on this. So taking a screenshot, bringing it into your favorite PDF editor, covering up 9 volts and then putting 5 volts on it. That's what I've done in my diagrams. It would be much better if this particular thing had a black box shaped thing like this that said 5 volts on it to represent the idea that this is a current source, a voltage source. I had another colleague say, why don't you just create an image of the actual voltage source that looks like the schematic that you could attach to the breadboard? I'd be down to do that as well. It's just I have other fish to fry at this point. So anyways, that's when you see this diagram on my wiring diagrams in the digital directions that I give, that represents the 5 volt DC source. So let me show you what I mean by this. There it is. That 5 volt DC source I attached to the 9 volt battery. These two red and black wires represent those 5 volts. If I say 2.5 milliamps, that's the idea that I can attach this particular current source and then attach it to here, and it provides 2.5 milliamps. And so you'll see that in my wiring diagrams. I just kind of label it with either 5 volts for a voltage source or milliamps for a current source. And you'll see this down here. Do you see that particular circuit where I've attached the 5 volt source and 1 resistor? So that would mean that I would take this voltage source, attach it there, and then connect it. And the reason that this is really powerful is, notice that this wiring diagram gives you a sense of how to connect it. Here's the associated circuit schematic. And in the circuit schematic, we are labeling both the source and its value. So each circuit element is labeled within type. And then we also define the value of that element there. And then the wiring diagram just tells you exactly how to do that. I will also give you really detailed instructions. So you'll see here, there's some really nice instructions on how to do this. We'll do our first build in future videos, but what I wanted to do is just get you kind of aware of the idea that these are called voltage sources. In order to power them, we attach the 9 volt batteries. The black lead we'll call the negative lead of the voltage source. The red lead we'll call the positive lead. We'll talk about what that means when we start measuring voltages using a multimeter. The corresponding circuit schematic associated with this looks like that part, and then we just saw how to see how to represent that in Fritzing. In the next video, we'll go ahead and talk about the current source, and we'll kind of compare and contrast, and we'll go from there. All right, I will see you in the next video.